Assalamualaikum and hi everyone. I'd like to introduce myself. My name is Ahmad Faris Hazid bin Hussein. Today we will discuss and implement our presentation title on the application of depreciation and solve the problem given. Here our presentation 1, Engineering Mathematics 2, and the code subject is DBM20023. Not forgetting our lecturer, Miss Nikia and Miss Bekria. First of all, I represent from Group 6. Will introduce our group member. Our group consists of 4 students, including me, Ahmad Faris Hazid bin Hussein, number matrix 10DEE21F1088, and Subli Kai, number matrix 10DEE21F1071. Muhammad Alif bin Anwar, number matrix 10DEE21F1090. Lastly, Muhammad Zamir bin Muhammad Zamri, number matrix 10DEE21F1053. Now I will explain our team role and responsibility. First, me, Faris Hazid, will explain introduction of differentiation and what is differentiation. Other content, for example of application of differentiation in real life, will be discussed by Alif Anwar. And our core member Subli Kai will solve a given question and explain the question clearly. And lastly, Muhammad Zamir will summarize our presentation. Our first content, I will introduce what is differentiation. In mathematics, this topic explains more on the techniques of differentiation. It covers the basic rule of differentiation, derivatives of trigonometric, logarithmic, and exponential function, second order differentiation, parametric equation, implicit differentiation, partial differentiation, and technique of total differentiation. It also explains application of differentiation in calculating the rate of change, in addition, solving maximum and minimum problems. So, in mathematics, the derivatives of function of a real variable measure the sensitivity to change of the function value with respect to a change in its argument. Derivatives are fundamental tool of calculus.
Hello, my name is Muhammad Alif bin Anwar from class DE2C. My matric number 01 DEE 21 F1090. I will present to you about application of differentiation in real life. First of all, I choose economics. Differentiation can help us identify the estimate profit in the sale of an item or the capital that needs to be spent in making an item on its total quantity. Differentiation helps a trader to make this decision in business based on equation made using differentials. After that, I choose engineering. In engineering, differentiation help with a lot of wear in the application of piston, which are widely used not only in shipping but always recycle. Recycle. Differentiation allow us to discover and apply the piston used in all areas. These findings are very important and useful to us as a result of this development. And lastly, I choose the rate of change. A lot of physical quantity that exist in our daily life change with respect to time. For example, an in electrical engineer may need to know the change of current in an electrical circuit with respect to time. Secondly, a building contractor may need to know the change of expansions of concrete mix with respect to time in the building of a bridge. And we call it the rate of change. That's all. Thank you very much.
My name is Solid Khai. My matrix number is 01DE2F1071. In the question, y equals to in bracket 2 over x and in bracket x cubed minus 6x squared plus 3x. When we know 2 over x equals to 2x power of negative 1. So y equals to in bracket 2x power of negative 1 and in bracket x cubed minus 6x squared plus 3x. So y equals to 2x squared minus negative 12x plus 6. In step 1, we should find out the differentiation of 2x squared minus 12x plus 6. So our dy over dx is 4x minus 12. Then step 2 is to find out the stationary point. Dy over dx equals to 0. Therefore, 4x negative 12 equals to 0. 4x equals to 12. X equals to 12 over 4. So x equals to 3. Then we going to find out the y. When the x equals to 3, by using y equals to 2x squared minus 12 plus 6. Y equals to 2 in bracket 3 squared minus 12 in bracket 3 plus 6. Y equals to negative 12. Therefore, 3 negative 12 is a stationary point. Then, in second degree function of 4x minus 12 is 4, and 4 is bigger than the 0. So 3 negative 12 is the minimum point. In the graph, we can set the point 3 in the x-axis and negative 12 in the y-axis for the minimum point. Then, by using y-intercept of x equals to 0, y-intercept point equals to 2 in bracket 0 square minus 12 in bracket 0 plus 6, then equals to 6. Then we can mark the point in 0 in the x-axis and the 6 in y-axis. Then we can connect it other by the curve shape.
Hi, my name is Muhammad Zamir bin Muhammad Zamri. My metric number is 01DEE21F1153. Now I want to continue our presentation about differentiation. Summary. In calculus, differentiation is one of the two important concepts apart from integration. Differentiation is a method of finding the derivative of a function. Differentiation is a process in maths where we find the instantaneous rate of change in function based on one of its variables. The most common example is the rate change of displacement with respect to time, called velocity. The opposite of finding a derivative is anti-differentiation. If x is a variable and y is another variable, then the rate of the change of x with respect to y is given by dy per dx. This is the general expression of derivative of a function and is represented as function x equals dy per dx, where y equals function x is any function. A function f is increasing over an interval I if for all A and B in I such that A smaller than B, we have function A smaller than B. Equivalently, the slope of the second line connecting A and B is positive. A function I is decreasing over an interval I if for all A and B in I such that A smaller than B, we have function A bigger than function B. Equivalently, the slope of the second line connecting A and B is negative. Stationary points. The second derivative function is used to determine the concavity of the graph of f. If function x greater than 0 for all x in an open interval I, then the graph of x is concave up over I. If function x smaller than 0 for all x in an open interval I, then the graph of f is concave down over I. If c is a critical value and function c greater than 0, then function c is relative minimum. If function c is a critical value and function c smaller than 0, then function c is a relative maximum.